All right. So at this point in our math careers in this unit, we should figure out and try to understand where it is we're coming from and where it is we're moving towards. Understand that what you're doing right now is stuff you've been doing, I think, beginning in grade 4, adding, subtracting, multiplying, and dividing fractions. The only difference is that we're using more complicated expressions and terms, things that can be factored, right? And so the goal is to come up with simplified versions of the answer. And sometimes you can factor them before you start adding, subtracting, multiplying, dividing. Sometimes you can factor them after, and sometimes in between. And often there's an easier way to do things, right? It makes more sense sometimes to factor first and then bluster through. Sometimes it makes sense just to bluster through and then factor the final answers. Okay, so it comes with experience a little bit. You figure out and you learn what technique or what strategy you're going to use depending on the question. So we are on page 145 of our workbooks, and as is usual, we're going to start off with a little bit of warm-up and practice because I want to show you, or at least remind you, of the theory that's going on behind the work we're doing here. Okay, so I'm going to move myself up here. Like many things in math, there's the proper long way to do things, and we show you this long way because it's more applicable and you understand how the math is working. And then there's shortcuts. So as an example of a shortcut here, 1/2 plus 3/4. Well, we know we can't add fractions with the same denominator, so we make an adjustment here. Instead of 1/2, we bump it up to something over 4, 2/4. And to that, we're going to add the original 3/4. All right. So, this should be second nature to you. This is going to be 5/4 overall, right? There's your answer, boom. But now it becomes important to understand what we've just done. And what we've just done sometimes, especially in a question like this, it's just a bit of overkill. It's just a little bit more work than you really need to do. But you're going to have to start needing to do that kind of work and showing those steps when we get to more complicated problems as we move on. So what we're really doing here is, and I'll do that on the bottom here, I'll do the long belabored process here, is we're taking the one up top and we're multiplying it by the opposite denominator. We're going to multiply 1 times 4. And then we're adding, of course, and then we're going to take the 3 and we're going to multiply it by its opposite denominator, boom, like that. Whether you know it or not, this is really what you're doing when you do this kind of thing up here. On the bottom, of course, will be simply the 2 times 4, okay? So how does this work out? Well, 1 times 4 is 4, 3 times 2 is 6. You're going to get 10 on the top and you're going to get 8 on the bottom. And then you can simplify that to 5/4 and you get the same answer, right? So this is the shortcut of how we're doing stuff. This is what we're actually doing. And sometimes you don't have to go through this whole mess, but when you get a question like this, you kind of sort of do. All right? So how does this look? Well, we can't simply add straight across because the denominators are not the same. So you look for a lowest common denominator, if you recall that term. And so what we're going to do is, well, you try to recognize what the factors are, and that's why we did factoring in grade 10. High performance factoring in grade 10. And you'll see quite quickly that the lowest common denominator, the lowest common multiple of both of these numbers is going to be 35, right? 5 times 7 to get you 35, and then 7 times the 5 to get you 35. But now to work with the rest of these numbers, you're going to have to go like that. Okay. So here's the 7 times 5 to get us to 35 in the bottom. Okay. And on the top, we're going to get 2 times 5, which is 10, minus 3 times 7, which is 21. And we are going to get out of this mess negative 11/35. Okay. You see here we actually have to go through most of the process to figure this stuff out. All right. So now let's take a look at a slightly longer and perhaps more perplexing problem. Again, there's nothing inherently wrong with this or difficult with this if you take it step by step. And what I like to do in a case like this is resolve all of the top stuff. I'm going to resolve all of that in a couple of steps or two, and resolve all of that stuff in a couple of steps, and then I'll do the full-on division. So how I begin then is add 1.5. Well, what's 1.5? 1.5 is like 2 over 2 plus 1 over 2, right? And altogether that's going to be just what? 3 over 2 in the top. And on the bottom, I'm going to have 3/4 minus, well, it'd be what, 8? To give me a common denominator of 4 in the denominator, like that. And so that's going to be negative, what, negative 5/4? That's what I get. All right. And now, the rule that you insist on is to invert and multiply. But I want to show you now why the invert and multiply actually works. What we're doing when you invert and multiply is you're really multiplying by something that looks and feels and smells a little bit like a conjugate of the minus 5/4. We are, in fact, going to multiply, not by the conjugate, but by the reciprocal of 5/4. And what's that going to do to us? Well, when we multiply the bottom by negative 4/5, we're going to keep the sign, but we're going to flip the terms. What are you going to get in the bottom? What is 5/4 times 4/5? Well, the negatives are going to multiply out to give you a positive. 4 times 5 on the top is going to give you 20. 4 times 5 on the bottom is going to give you 20. 20 over 20 is going to equal what? 1, right? And so we're going to be able to get rid of the fraction that way. But when we multiply, we have to multiply this number by an expression that equates to 1. And the only expression that equates to 1 is negative 4/5. And so on the top now, we're going to get a negative. And now this is straight up multiplication in the numerator, rather. 12 over 10. And it's all divided by 1, so we can get rid of the 1 here. And we're going to get negative, I guess the most simplified form would be negative 6/5, right? So this is the long belabored approach showing you why invert and multiply works. Well, let me show you invert and multiply all by itself. And we're going to start with this expression right here. 3/2 divided by 5/4. 3/2 divided by, and it's negative 5/4. 3/2 divided by negative 5/4 is the same as 3/2 times the inverse of the denominator, negative 4/5. And look what you get here. You get negative 12/10. Whoops, that's a negative there. Okay, which is negative 6/5 when it all simplifies out. So take a look. So here is what you've learned to do when you divide fractions. You invert the denominator and multiply the numerator by the denominator. So there's the numerator right there. Okay, it stays the same. You invert and multiply by the denominator and you get the same answer. This is why it works. This is how it works. So likewise, when I showed you how to do a complicated way of this, right, you know how to do this. This is why it works. We're going to have to start using these slightly more complicated methods to figure stuff out because we're going to be dealing with complicated expressions. So what that means is, and when we're looking at something like this, we can simplify and come up with a rule. All right, A over B plus or minus C over D is going to be A times D plus or minus C times B all over BD, just like that. It's as easy as that in learning what we're doing here. we're taking the d, cross-multiplying it, and creating a new expression. The numerator is going to be not necessarily the lowest common denominator, but a common denominator. And then later on, when you get a little bit of stuff going on, when you get more closer to a final answer, then you can start factoring out and dividing out and simplifying your expression. So that idea of the common denominator is the king. That's the whole point of this. All right. So let's put that into practice here, using this kind of rule and expression here. 2 over x plus 1 over 3 is going to be equal to 2 times 3 plus 1 times x all over x times 3. Now we don't usually put the variable in front of the coefficient, so we'll clean that up in the next step. 2 times 3 is 6 plus x. 1x is just x, yeah? And 3x, like that. And there's no other simplification we can do. We can't divide 3's out because there's no coefficient in front of the x. It's also 3. So this is the final answer. But now that we're dealing with x's and y's and variables, we have to look at the non-permissible values, the restrictions on the value of x. And if you look at x down here, of course, you know immediately that x may not equal to 0, so we have to state it explicitly. All right, and there is your full, complete, simplified answer. Boom. All right, well, now we got a little bit, more complicated of an example. These class examples are all meant to show you different techniques. There are literally dozens of techniques, and we don't have the time to go through all of them, but we give you some of the major ones, and then you start learning, well, maybe I'm going to do this over here or that over there to solve the questions as we move on, okay? So you have to ask yourself what the common denominator is between b squared and a squared b. Now, one way to get a common denominator is simply to multiply ab squared. That will always work, but you make a little bit more complicated expression right from the beginning, which you will then simplify, and it'll all sort out in the end. But we can do a little bit of simplification straight up if we realize that a squared b squared would be a common denominator. So you ask yourself, well, what do I have to do to 2 over a b squared to get a squared b squared? Well, I'm going to have to multiply it by a, aren't I? I'm going to multiply the top and the bottom by a squared b squared, right? Right? If I wanted to simplify this, the a's would divide out, and I come back to the original thing there. See what I've done? Minus, and you're going to ask yourself the same question. The lowest common factor, well, we're bringing it down. We know we're coming down to a squared b squared because it has to match this denominator. And so what did I have to multiply this whole term by to get it out of a squared b squared? Well, I had to multiply it by b, just like that. All right. Well, let's keep going here. We know we're going to have a big, long fraction that's going to be under a squared b squared. That's our common denominator. And 2a minus 8b, just like that. And we are pretty much, I mean, you could factor out the 2 if you want. 2 bracket a minus 4b. I think we're going to leave it like that for now. This is your finished expression. The only thing you need to do now is worry about your non-permissible values. And it seems that neither a nor b may equal to 0, because if they were, then the denominator would equal to 0, and the whole expression would become indeterminate or undefined. And the same thing works here. If a or b is 0 in any form of the expression, you have to look at each form. Well, in each form, this one, this one, and this one, it's all a and b may not equal to 0. And there is your final answer. Boom. All right. We're ready to try some harder stuff now. Yeah, we are. Ready to go? Let's go. Let's make it a little bit more challenging now, okay? And even so, it's not that challenging. I'm going to start going a little bit more quickly now. The idea is always to try to get a common denominator. Sometimes you can figure out a lowest common denominator, cool if you can, and if you can't, well, we're not going to worry about it. So here's an example where I'm not going to worry about it. I'm going to just make my my common denominator x plus 3 times x plus 2, okay? And so what I'm going to do to the numerators to get that on this side is I'm going to cross multiply. So I've got 5 times x plus 2 plus 8 times x plus 3, like that. And, well, what's my next step here? I guess, I can't divide out anything because x plus 3 is not common to both of the terms on the top, right? It's only common to this one. So not much to do except expand and see what we get out of this whole mess. Well, when I expand the top, I'm going to get 5x plus 10 plus 8x plus 24. And I'm just going to leave the bottom in its x plus 2, comma, times x plus 3. Good. And now I'm going to take this numerator and I'm going to see if I can simplify by gathering like terms. Well, 5x plus 8x plus 10, I'm going to get 13x on the top. 13x plus looks like 34. And x plus 3, x plus 2 on the bottom. I don't think there's any more simplification I can do here. And I can't do any dividing out. The only thing and the last thing I need to do is state my non-permissible values. X, what may x not equal? Well, if you look at the denominator here, x may not equal to -3 or -2. Okay, and let's just take a look up here. That's the same condition here and the same condition here and the same condition here. So we are good to go here. X may not equal to -3 or -2. There is my final answer. Boom. Now I want you to imagine, instead of 13x plus 34, let's say I had a quadratic in there. And let's say that quadratic was factorable into integer values and I had a x plus 3 or an x minus 2 there, or an x plus 2. Then I could start dividing stuff out and make it even simpler still. That's where we're headed for. All right. So on this question here, we start getting a little bit tricky and we start learning some of those techniques that you can use to simplify your life. I want you to look at the two denominators and I want you to notice that they look awfully similar. They're not the same, but they look awfully similar, don't they? It's just the, well, some of the signs are different and the values of the terms and the terms are sort of reversed, are flipped, right? It'd be nice if we could get everything under the same denominator so that I didn't have to multiply this and this. You could go m times brackets 5 minus m plus 3m minus 10 times m minus 5. And then all over m minus 5, 5 minus m. Absolutely could do that. But we can simplify our lives just a teensy little bit if we were able to change the 5 minus m into something that looked like m minus 5. Well, how do you do that? Well, you realize you do that by realizing that 5 minus m is the same as -m plus 5. All right, so there we got the terms in the correct order. We got the m first and then the 5. And then I'm going to divide out or factor out a -1. So -m divided by -1 is just going to be positive m, and then 5 divided by -1 is going to be minus 5. And boom, all of a sudden, you've got the same kind of term here and here. And this really does help you come in because this will affect that. This will just flip it around, and then we've got the same denominators. What does that look like? Well, it looks like this. We're going to have m over m minus 5. Now, instead of a plus, we're going to have a minus because this is turned minus. And on the top, we're going to have 3m minus 10. And on the bottom, we're going to have m minus 5. Okay? So we've got the same denominators now. The operation has changed because we've divided now by a negative number in the denominator, right? And so the next step will be simply to put it all under the same denominator. It's m minus 5, and it's going to be m minus 3m minus 10. And this is going to be equal to, this is going to be plus, because minus 3m minus a negative will be plus 10. And so we're going to get negative, looks like negative 2m plus 10 over m minus 5. And we're pretty much done. The only thing I want to do is pretty up the numerator here and bringing out the factor of 2. So I'm going to pretty up by going 10 minus 2m over m minus 5, and then factoring out a 2. So 2, which is 5, minus m over m minus 5. Isn't that pretty looking? All so simplified. Last thing, of course, is to think about your non-permissible values. Well, m cannot be equal to 5 here, m can't be equal to 5, m can't be equal to 5, m can't be equal to 5 here. Here it doesn't matter. Well, I guess that's negative 5, isn't it? Yeah. So m could not be negative 5, but then, yeah, because then this will blow up. So x may not be equal to plus or minus 5. Isn't that wonderful, and isn't that elegant? Now, wait just a minute. So here I am, laying on my couch in front of my fireplace, and I'm editing down this video for you, and I notice something. What do I notice? Well, you know, when you do questions like this, you know that sometimes you just get into a rhythm and you sort of do things in an automatic mode. You don't notice things. But this is question B on page 146, the one we just did together, okay? And I want you to look at what we did here, okay? So we said 2 times 5 minus m over m minus 5, and then there's the final answer. Boy, oh boy. Well, I noticed something just as I was editing and saying, wait a second, we can do one step better. And it all starts with, instead of going to these steps, there's nothing wrong with that. That is correct. It's just that we can come up with a more simplified version of that. And you're going to see how beautiful that is in just a second. We're going to start with that, okay? So let me replace this with this. And let me just copy down what I just had there. We had 10 minus 2m over m minus 5, okay? So here's how I think I want you to take a look at it. Remember how at the beginning of the question we rearranged the denominator of the right side from 5 minus m to negative m? Okay, we can do the same thing here. Because this is going to equal to negative 2m plus 10 on the top. I'm just reversing the order of the terms in the numerator. Still divided by m minus 5 in the bottom. Cool. Now look what I'm going to do. In the numerator, I'm going to factor out a negative 2. And when I factor out a negative 2, I'm going to have m minus 5. Whoa! What am I going to have in the denominator? M minus 5. And if you don't see it, let me put this around it just to make it really obvious. Negative 2 times m minus 5 divided by m minus 5. Ta-da! Look at that. Now my more simplified, or if you want to coin a phrase, my simplifieder version of this is simply negative 2. Isn't that a lot nicer looking than this mess here? 2 times 5 minus m over m minus 5. Restrictions are the same. X may not equal plus or minus 5 because of what you see here and in the original. That is going to be an even nicer, eleganter version of a final answer, fully simplified for your mathematical pleasure. All right, I return you to regularly scheduled programming now. That's what this algebra is all about. There's elegance here. Now we set up these problems to be elegant and to show you how simplifying and unifying your rules of algebra can be. When you're working in the real world, you've got messy numbers and things do not simplify. But when you're learning algebra, we try to show you these little tricks and tips with the idea that you might be able to apply them in more complicated formulas in some kind of real-life application. All right. X over x plus 3 plus x plus 1 over 4. What do we got here? Well, we're going to just use the basic technique of cross multiplying, okay, the cross products here. So 4 times x plus, and then this times this, right? So x plus 3 times x plus 1, okay, all over, and then we're just going to multiply 4 times x plus 3 to give us a common denominator. All right. Well, let's do some expanding then. Okay, it looks like we're going to have to do some work here. So we get 4x plus, and so we've got a couple of binomials here. We're going to do binomial expansion. I will do it very quickly because you should be used to doing that. There's an x squared. There's a 1x, and then there's a 3x, so there's another 4x right there. And then there's a 3. Okay, so I've just done the binomial expansion here, x squared plus 4x plus 3, divided by 4 over x plus 3. Now I'm not going to multiply, I'm not going to expand the 4 times x plus 3 on the bottom for a moment, just to show you, because maybe we'll be able to factor that 4 out, or maybe we'll be able to factor that x plus 3 out. Wouldn't that be nifty and nice? Well, let's go see what we have going here. When I combine like terms and then rearrange my trinomial, I'm going to get x squared plus 8x plus 3, it looks like, all over 4 times x plus 3. Now, you might have to think about this for a bit. Does x squared plus 8x plus 3 have integral factors? It doesn't. But if it did, and if x plus 3 were one of those integral factors, then you can see how I might be able to divide out the x plus 3. It doesn't. As it turns out, this is as simple as you can make it here. This is your final simplified answer. What are my restrictions on x, my non-permitted values? Well, if x were -3, then this would be 0. We can't have that in the denominator. Same thing here, same thing here, same thing here. So x may not be equal to -3. Look at that. I keep threatening that you're going to be able to have numerators and denominators which you're going to be able to divide. If you look for factor, you got a trinomial and you factor a quadratic and you factor it. Maybe we'll get one here. I don't know. Maybe we'll get lucky. It'd be nice if we got a nice little complicated one that just became simple, simple, simple. 3 over x squared minus 4 minus 8 over x plus 2. All right. So where to start here? Well, it seems obvious that I'm going to have a common denominator of x squared minus 4 times x plus 2. Maybe it makes sense. Well, I think it might be a little bit easier to figure out if I factor that x squared minus 4, because I hope you recognize that as a difference of squares, isn't it? Yeah. So we're going to keep the 3 on the top, but instead of x squared minus 4, we are going to give ourselves x plus 2 times x minus 2. Yeah? Boom. Just like that. All right? And we're going to subtract from it, x plus 2 and 8. Cool. And now you see that really all we need to do is multiply this right side by x minus 2, and that would give this right-hand set of terms the same denominator as this, right? If we multiplied this by x minus 2 over x minus 2, then we would have this all set up and nicely done. I'll do it, like I said, there's lots of different ways to do it. I'm going to do it the more complicated way, just to show you that it can be done. But if you wanted a simpler way of doing it, maybe all you got to do is multiply the right side by x minus 2 top and bottom. But we're going to do the full meal deal here. I'm going to do the cross product here. 3 times x plus 2. Just make sure I've got that right. 3 times x plus 2 minus 8 times x plus 2x minus 2. Okay, so I multiply. So it's this cross product minus this cross product all over x plus 2, x minus 2, and x plus 2. Remember, this operator here and this operator manifests itself in the numerator. The denominator, or for the denominator, we're multiplying all three of these terms out, and here they are. So there's no plus or minus here. It's just multiplying the whole mess out. All right, so remember, I'm doing this a little bit more complicated. You could do it slightly more easily, but I just want to prove to you that the long and labored bluster through method still works, and to show you how that still works. Well, before I go any further, I can do some dividing out. Notice I've got an x plus 2 here in the denominator. I've got 2 of them actually, but I've got 1, and I've got an x plus 2 here on both sides of the operator. You know what that means? That means that I can divide those 2 bits out, and I can divide this and this one out. So I can simplify the expression a little bit before I take it up another notch. And when I do, I'm going to get 3 minus 8 times, and I've just got an x minus 2 left over there. Now this is important. It's minus 8 times x minus 2. And remember BEDMAS, right, which you learned in grade 6, grade 5, I can't remember. But it means that we're going to have to do this first before we do any subtracting out. All of that is going to be on a little bit simpler denominator of x plus 2 times x minus 2, just like that. And I cannot divide out the x minus 2, because although there's an x minus 2 on this side of the operator, there is no x minus 2 on this side. It's just 3. It's not 3 times x minus 2. If it was, then I could divide that out, divide all 3 things out. But I cannot, alas. All right, next step. Let's go to simplifying the top a little bit. What am I going to get? I'm going to get 3 minus 8x minus 8 times negative 2, in other words, plus 16. Yep, I sure am. And on the bottom, we're just going to keep the x plus 2, x minus 2, just because we can. And let's gather some like terms here. What am I going to get? I'm going to get 3 plus 16, because I want the minus to be on the other side, on the second term up there. So I'm going to go 19 minus 8x over x plus 2, x minus 2. And I'll look for some common factors I can pull out of the numerator. There are none. Nope, there are none. There are none. So all I have to do now is figure out what my non-permissible values are. X may not be equal to either plus or minus 2 because of that situation. That satisfies this, it satisfies this, satisfies this and this, so we're good. X may not equal to plus or minus 2. But do you notice anything else? No, that takes care of everything. There is my final answer and my non-permissible values. Done. All right, one last one. All right, we're back for the last question. There's a lot of room on page 147. You know what? At this point, it's just easy peasy, fairly simple algebra, bringing together everything you know about quadratics and factoring and rational expressions and operations. 3x plus 15 divided by x squared minus 25. Does the x squared minus 25 look sort of familiar to you as a difference of squares? Well, it should. All right, it really should. 4x squared minus 1. Hey, that's kind of cool. That's also a difference of squares. How can you tell it's a difference of squares? Every single term in the expression has to be a perfect square, and it has to be a negative or a minus operator. So 4 is a perfect square of 2, x squared is a perfect square of x, and 1 is a perfect square of 1. So these are both, these cross products or these cross terms here, numerator here and the denominator here, are both perfect squares. And that sort of begs you. It says, please, 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 do me first. Do me first. All right? So I'm going to do a couple things here. I'm going to take this first set here, 3. I'm going to factor out a 3. I'm going to get 3 times x plus 5, because you never know if you're going to need that x plus 5, or if you can use the x plus 5. And then I'm going to factor out the the difference of squares, x squared minus 25, which is x plus 5, x minus 5. Oh, hey, look, x plus 5, x plus 5. You can do some, should we tick off the mathematical gods and say canceling out? Yeah, we can cancel out there. Anyways, let's finish it off. Plus 4x squared minus 1. Remember I told you that 4x squared minus 1 is also a perfect square of 2x plus 1 times 2x minus 1. And just take a moment and confirm. Let's expand the binomial. 2x times 2x is 4x squared. Boom. Plus 2x. Oh, sorry, minus 2x plus 2x. Whoops. Plus 2x. There we go. Okay, they subtract out. Minus 1. Yes. So 2x plus 1 times 2x minus 1 are indeed the factors of 4x squared minus 1. And 2x squared plus 9x minus 5. Well, you know what? The more you get used to it, the more factor quadratics that you see and factor, the more it's going to become apparent when things are factorable. You know there's going to be a 2x term in here to get to the 2x squared. You know that. And it's just a matter of figuring out where the minus and pluses go. Okay, that's all just experience, right? I know the minus goes next to the bigger number because the minus is at the end. So I know it says 1 and I know it says 5. And then again, double check just to, if you don't believe me, just expand out. 2x squared plus 10x minus x. There's 9x minus 5. Yes, indeed. There we go. So you've done the factoring first before you've expanded. I mean, you could go, if you really want to go crazy, you can go 3x plus 15 times 2x squared plus 9x minus 5 plus 4x squared minus 1 times x squared minus 25. Okay, see where I got that, right? I'm just doing the cross products all over x squared minus 25 times 2x squared plus 9x minus 5. Okay, you can go ahead and do that, and you can't see it, but you can go ahead and go do all that mess. Okay, you're going to end up with x to the 4th terms. Do you know how to factor x to the 4th? Nope. There is a formula for factoring cubic functions, x to cubed. It's called the, well, if the factoring quadratics is the quadratic formula, factoring cubes is the cubic formula. There is one, and it's complicated. But let's try to avoid that. Hey? Let's try not to have to do that. Because look what we can do once you've done some factoring up ahead. Remember, I've been telling you that sometimes you can use the ability to factor to your benefit to simplify before you do all the rest of the stuff. Well, x plus 5, divide out. You see a 2x minus 1, 2x minus 1. They divide out. All of a sudden, you've become very, very, very much more simplified. How simplified? Well, we got 3 over x minus 5 on one side, plus 2x plus 1 over x plus 5 on the other side. Now I'm afraid there is nothing for it but to do your cross products. So 3 times x plus 5 plus, I guess I'm keeping the numerator first, so 2x plus 1 times x minus 5 all over x plus 5, x minus 5. I don't know, I just like to see the positive expression first. I mean, remember, a times b is the same as b times a, so it doesn't matter what order the multiplication happens. From there, what else can I do? I cannot divide out x plus 5, because if I want to divide this out, this would have to be on both sides of this. And it isn't. And remember that this is this expression times that. All right. So let's continue here. Let's do some expansion on the top. Okay, so I have got to expand that, and I'm going to get 3x plus 15. Oh, hey, remember, look, I had 3x plus 15 way back there. Now I'm getting it back. Okay, so you might say, well, why did I have to go through all that bother for? Well, because it allowed you to do the dividing out up here. So 3x plus 15 on the top, plus, and then I'm going to do this binomial expansion. That's 2x squared minus 10x plus 1x. So that's minus 9x minus 5. Okay, all over. And I know you can multiply out the x plus 5 times x minus 5. You get the x squared minus 25. Let's just leave this here for now. Okay, let's just leave this here for now, because the goal is to leave it in the most simple format, and this is simpler than this. All right. All right, let's gather like terms on the top. I've got 2x squared minus, looks like this and this, so it looks like minus 6x. And it looks like plus 10, don't it? Yep, I think we're good. All divided by x plus 5 times x minus 5. Booyah. Well, I can look at this and I can tell you it's factorable, but not with integral factors. If you use the quadratic formula on this, well, if you use a quadratic formula on this, I think you'd discover that you had something that looked like up opening, stretch. I think it'd be looking like that a little bit, right? So no x-intercepts, so we won't be able to divide those out. Okay. It looks like the only thing you can do is factor out a 2. So let's do that. Let's go 2 of x squared minus, 3x plus 5 all over x plus 5 times x minus 5. That looks to be as much as I can do here. And the last thing I have to worry about are my non-permitted values. Well, I've got 5s here, so x may not equal to positive or negative 5. Good. Anywhere else, that takes care of this. Oh, I should clean up my parentheses there. Oh, it looks like we have to worry about this one up here. Do you see a 2x minus 1? Looks like x may not equal to 1/2 either, because if it did, then this would be 0, and this would all be indeterminate. And if one side of the addition or subtraction is undefined, then the whole thing is undefined. And so you have to look for non-permitted values in all of your denominators. And we are done. Yay! Praised be his newly appendage, who gives us algebra to solve questions like this. You guys take care. Hit the question starting on page 148 and math your little hearts out. Peace out, man.